Hello, we are continuing with our nuclear processes and we are continuing from where we stopped in our first video. This time we are going to look at another part of nuclear processes. We looked at the different atoms and we saw what defines atoms as the particles. They are the particles that make up an atom, the other fundamental particles that determine the mass of these atoms. However, we are going to discover that we have some heavy, very heavy atoms with very heavy nuclei. These kinds of atoms with heavy nuclei are always unstable. They are always unstable. And these kinds of unstable nuclei of different atoms always undergo what we call decay or radioactivity. This kind of a process, what we call decay or radioactivity, will always be the spontaneous or the continuous disintegration of these heavy unstable nuclei to form stable nuclei with emission of particles. So this kind of decay will always be involving emission or loss of particles. And these particles will be known as they will always be known as radioactive particles. These kinds of particles will always result into spontaneous continuous breakdown of these large unstable nuclei to small stable nuclei. This kind of disintegration or breakdown of such nuclei will always be accompanied by emission of particles. This kind of particles will always be either alpha particles, beta particles, or gamma particles. So the particles that will be emitted will either be the alpha, the beta, and the gamma. These particles emitted are the ones that determines the kind of disintegration these heavy nuclei undergo, and it determines the kind of daughter nuclei that will be formed. So the daughter nuclei formed from the parent unstable nuclei are always slightly more stable compared to the daughter nuclei. So in short, decay or radioactivity will be the spontaneous disintegration of heavy unstable nuclei forming small stable or light stable nuclei with emission of particles. In short, I'm saying that the radioactivity will be the spontaneous disintegration of heavy unstable nuclei to form light and small stable daughter nuclei with emission of particles. And we've said that these particles are simply alpha, beta, or gamma particles. Let me think we are moving together. I do not want to leave anyone behind. So we've said that those particles may also be known as radiations. May also be known as radiations, radioactive particles. And they are of great contribution to modern life, to modern science, like we are going to see. Each of these particles has specific or special properties. And we shall start with the beta particles. The beta particles, we are going to find that they are high-speed moving helium particles or atoms. No, we are starting with the alpha particles, sorry. We said that these particles can also be known as radiations. And we are all used to this word radiation. It's not very new. It's not new to any of us. And I've said that the alpha particles are simply high-speed helium atom. And if you know very well, helium is a group 8 element. The other pseudo range of the periodic table up in the group 8. And the alpha particle will always be represented as this. So the moment any atom decay with emission of an alpha particle or alpha particles will always emit a helium atom. When I say emitting an helium atom, I mean that the mass number of that mother nuclei or nucleus will always reduce by 4, and the atomic number of that mother nucleus will always reduce by 2. We said the elements whose atoms are unstable, or whose nuclei are unstable, will always be termed as radioactive elements. So the radioactive elements that will decay by emission of an alpha particle, their atomic masses will be reduced by 4, and the mass numbers and the atomic numbers will be reduced by 2. Let me think I'm flowing. So in short, the alpha particle has the following properties. They are always positively charged. So the characteristics of alpha radiations. We are stating some of the characteristics of the alpha radiations, and we are saying that the alpha radiations, they are positively charged. Why? Because the helium atom has remember, the helium atom has 2 protons and 2 neutrons, but it lacks electrons. So the lack of electrons in the helium particle will always leave the helium particle positively charged. That's why it is having, the 2 down here is only representing the number of protons. It does not have electrons. So that's why it is positive. It lacks the negative charges on the electrons that would balance the 2 protons inside its nucleus. Let me think I'm flowing. These alpha radiations have the least penetrating power. In the way that they can even be stopped by a thick piece of paper. Even a thick piece of paper can stop alpha radiation. They have the least amount of penetrating power, but with the greatest ionizing energy. We are giving some of the properties of the alpha radiations. They are positively charged. We've mentioned that. They are a helium atom or a helium nucleus, like we said. It is an atom. We are true to say nucleus because for it has no energy levels due to absence of electrons. Their speed, or the speed of these alpha radiations, is more or less compared to the speed of light. They are slightly deflected by both magnetic and electrical energy, or electrical energy, due to their large masses. We are talking about the characteristics or the properties of alpha particles, as you're stating. For flowing. So they have the shortest range in air. These alpha particles, like we said, they are slightly deflected by magnetic and electric fields. The reason given is because of their large masses. To mention but a few, like we said that the mother nuclei, for them to disintegrate in the way to give a daughter nuclei by an alpha decay, they will always emit a helium atom or a helium nucleus. And this means if the mother, this is the mother nuclei or nucleus, the mass number of the mother electron the mother nucleus will always reduce by 4, and the mass, the atomic number will always reduce by 2, such that it forms a daughter nucleus. So if we had, let's say, a nucleus of an atom, we call it still Y, with 236 as the mass number and atomic number of 102, will only decay to form a daughter nuclei X by emission of alpha particle. When this one reduces by 4 and this one reduces by 2. So for this we shall have, to get X, the values on X, we shall have 236 equivalent to this number, which is Z, which is an A, minus 4, if it is only one alpha particle that was emitted. And then to get this one, which is Z, will be reduced by 2. Let me think we are flowing, which was 102. So this means we shall collect like terms for this one. We shall have 236 plus, actually, minus 4 to have that figure you have, which is a 232. So here we shall have 232, and down here we shall have 102 minus 2, such that we get the value of Z as 100. So why after this, after emission or after decay by emission of alpha particles, will form a daughter nucleus of this, of mass number 232 and atomic number 100. That is by emission of an alpha particle. So it depends on the number of particles you are told. We didn't mention some of the examples of heavy nuclei. We can talk of uranium. Uranium is one of the heavy or radioactive elements. It is a radioactive element because it has a very unstable nucleus. It is very heavy. We can talk of plutonium, is another one. We can talk of polonium. We are mentioning some radioactive elements. We talked of uranium. We can talk of plutonium. We can talk of polonium. All of these are some of radioactive elements. They have very unstable nuclei, very heavy nuclei. To continue, so there are some applications of alpha decay in everyday life. These things are very crucial. So the alpha decay is used to date organic materials. There's what we call carbon dating. It is used to determine the number of fossil fuels that lived, of things that lived long ago. For example, the age of rocks, age of bones, all organic materials. The alpha decay, so we can mention some applications. Some of the applications of the alpha decay. Like we said, it is used to dating organic remains, such as bones. The wood, I found a certain video on YouTube. They were determining the age of a certain boat they discovered. The boat had lived for hundreds of years back. They were able to know that the wood that made the boats, that boat was of that age by determining the amount of carbon-14 that was present. So this is an application of alpha decay. So this is done by determining the amount of carbon-14 present in that remain that is present. So this is one of the applications of alpha decay. The alpha decay is used to detect presence of impurities in chemicals. We hear there are people who are always taken to test for presence of toxins in the diet. They always use alpha decay to do that. People who die of poison. They are used. Alpha decay is used to detect presence of radioactive additives in food, water, or air by research companies. Remember, most of these are taken as poisons, irreversible poisons, irreversible inhibitors, since they are heavy metals. So they always use alpha decay to detect for their presence in the food before it is distributed for use. We've ever heard that uranium, which is one of the elements that decay by emission of alpha. We know that it is used. We've ever heard about this. It is used to treat prostate cancer. We've ever had a radiotherapy treatment in the cancer patients. It is radio decay, it is alpha decay they use in this kind of treatment. We are giving some of the applications of alpha decay. Um, so alpha decay produces energy in form of heat that is used um, to kill cancer cells. So remember, on the equations you always make, as any atom, for example, why this, for any atom to decay with emission of alpha particles, like I'm going to use this general equation, we said the atomic number will be reduced by 2 on the daughter atom and the daughter nucleus, and the mass number will be reduced by 4. So this is always defined as an alpha decay. But among the products formed, there is also energy. This kind of energy may be light, or sometimes it may be heat. And among the properties of alpha radiations, we shall find that alpha radiations cause fluorescence of fluorescent substances, will cause shining of substances which absorb light and emits it as light of larger wavelengths. So these alpha particles, when absorbed by fluorescent substances, we shall have some examples. We looked at calcium nitrate. It is one of the fluorescent substances. When absorbed, when these alpha particles, alpha radiations strike any fluorescent substance, the alpha particles will be absorbed by that fluorescent substance and emit the energy from the alpha radiations as light of very high wavelength, colored light. So it is another application. It is used in fluorescence of fluorescent substances. So I would say the alpha radiations are always absorbed by fluorescent substances to emit light of higher wavelength. So that is another application and still a property. When absorbed by fluorescent substances, will always force these such elements to emit light, but this light of higher wavelength. We know the disco lights. We've ever seen them. There are these big lights they use in labs. Such elements, in such lights, they always put radioactive elements, which when emitting alpha particles, they always strike fluorescent substances that are put in them to emit light of a very high wavelength. So to cut the story short, that's all about alpha decay, and we shall have some questions in the WhatsApp group. We said those who are not part of the WhatsApp group, kindly reach us on 0703 27 82 31. We said we am to online, and we are grateful for always following us. But before I forget, the number of alpha particles emitted will always affect the number or the extent to which the atomic mass and the atomic number will be reduced. If an element emits 2 alpha particles, it means it has emitted 2 helium nuclei, where this mass number will reduce by 4 times 2, and the atomic number will reduce by 2 times 2. We should not forget that. So any number in front here always determines a lot, the amount or to the extent to which Z and A reduces. So with that, I request we meet again in the next video to look at beta particles. Thank you.